Welcome back to another beautiful day of Algebra 2. Today is Wednesday, September 4th, 9/4, 2019. Make sure that you have your name and date on the paper. So, who wants to read the objective? Ellery, first hand, go.
Multiply monomials by polynomials.
Perfect, 50xp to Ellery. Thank you, Brian. All right, so if these notes look familiar, that's because they were from Algebra 1, the exact same notes from, and I think from last year too, because I did this Algebra 1 lesson in geometry. Go for it. We'll catch you up. I think India's really good at catching people up. All right, so the difference between adding and multiplying. When I add 2 plus 2 plus 2, easy XP here. I think we know how to add, Caroline. It is indeed 6. It's going to be 50 XP to Caroline. Thank you, Brian. I know you're already doing it. And then when I'm multiplying 2 times 2 times 2, that is going to be, Ellery?
8.
That is 8. So the difference here, obviously, is one is counting how many ones there are versus how much area there is. This would be volume. This would be length. That isn't too important for now. The main thing is these two categories down here. So what is counting how many times you added the same number? Is it the coefficient or is it the power? What is counting the number of times I've added the same number or the same variable? Again, you have a 50-50 shot. Is it the coefficient or is it the power? Quiet raise hand, Oscar. It is the coefficient here. Thank you, Oscar.
Thank you, Bob.
The coefficient is counting the number of times you added the same thing. So if I add x squared and x squared and x squared 3 times, then I have 3x squared. The coefficient counts the number of times I've added this same variable. So far, so good. Sam's up. All right. All right. What's the other word for this column? The what counts how many times you multiply by the same number. Ellery. The power. Thank you, Ellery. The power, or the exponent, whatever word you want to use here. So I've already had two x's here, x times x, x times x, x times x. How many of those x's were being multiplied? Well, 2 plus 2 plus 2 is 6, so this is going to be x to the power of 6. Because this is really x times x will give you x squared, times x to get another x squared, times x to get another x squared, for a total of 6 x's being multiplied together. This should be review. We're kind of remembering the stuff from last summer, before the summer. Right? Nodding our heads, we're awake. Oscar, can you close your laptop? Colby, same thing. All right, so our old rule of multiplying bases that are the same. What happens to the powers? And you can probably guess, just based off of this last problem, this is going to be x to the power of what? What goes up here for the power? Quiet raised hand. Colby. It is n plus m. There it is. Whenever you have the same base and you multiply, you add the powers. Thank you, Brian, for giving Colby the 50 XP. This is the most important rule from today. If I were to go back and Cornell my notes tonight, I would come back and say, hey, this is important. I would highlight, I would circle this. This is cool. This will get me through the entire lesson. When I have coefficients a and b with the same variable x and x, what is going to happen? I'm still going to have x to the power of n plus m because I have n and m just like the same problem beforehand. But the difference now is, it always does that, is what? What is the coefficient? Quiet raised hand. Beverly. Oh, you weren't raising hand?
I'll answer it.
Go for it. Go for it.
A times b.
A times b. The coefficient here is a times b. That is the main rule for today. All right, let's turn this rule into words. When multiplying polynomials, I do what to the coefficients, and then I do what to the exponents. I'm looking for operation words, like subtract. Operation words. India, go for it.
When you multiply polynomials, multiply the coefficients.
We'll get the other one to someone else. Yeah, multiply the coefficients. Perfect, thank you. I know you're ready to do the next one. Multiply. A and B, these were the coefficients. They were multiplied together. Who wants to do the next word? What operation? I'm going to do what to the exponents, Lorea? Add the exponents. Thank you, Lorea. Kill me, Arrow. You kill me, Arrow. All right, Brian, you're all caught up. You're good? All right. So let's move down here and actually apply this rule where I multiply the coefficients and add the exponents. Example 1. Who can multiply the coefficients and add the exponents for us? Anna.
So, you -3 times 2, which is -6. Then we do x4 plus 2, which is also 6.
There it is. Thank you, Anna. Is it one of these? Is it Jaden? Is it one of these?
Oh, I just had a question.
So the sign language for Q? All right. Oh, yeah, he has a question.
What was the AX thing again up top?
Up here, that's the rule.
A, B, in parentheses, and then X plus?
I just put parentheses so that everyone could recognize those were the coefficients.
Okay.
All right. Any other questions? Let's try example 2. You are all going to do this individually and check with your neighbors. Do this now. Multiply the coefficients, add the exponents. Check with your neighbor. If your neighbor is struggling, help them. Brian is looking out and I am looking out for helping, and then you get ADXP for doing that. Quiet raised hand. Who has an answer? Everyone should have an answer. Jaden,
Oh. Alright, so I did 7 times 4,
which is?
28. And then I put that fancy old K right there. And then I added that 6 and that 10. And they made a 16 together. And that was my answer.
There it is. Yeah, thank you. You guys are doing a good job. All right, so eventually today we're going to do problems like this. 6x to the power of 3 times this giant trinomial, tri meaning 3 terms, 3x squared minus 2x plus 4. There is a shortcut, a nice little method in order to keep your answers correct. Eventually we're going to do binomials times trinomials, or maybe even trinomials times trinomials. This area model is a good way of keeping your work organized. You have 3 assignments tonight on Khan Academy. The first assignment is doing monomials times monomials. This one term times one term. The next one is using area models, because I really want you to know area models, and then apply the area models to problems that don't have any area where you have to set it up yourself. Those are the 3 different tasks that you have. So let's try this one. I set up the area model for you. I set up 3x squared minus 2x plus 4. I didn't have the plus because it's just a positive 4. And each of these is going to be multiplied by 6x to the power of 3. So I'm going to call on 3 people. The first person is going to say what 3x squared is times 6x to the power of 3. What is the term that will go in here? With a quiet raised hand, again, what is 3x squared times 6x cubed? Quiet raised hand. There should be many, many more people raising their hands, hopefully. Caroline. It is indeed 18x to the 5th power, 50x cubed for Caroline. Quiet raised hand, the next one. I think Brian got it, yeah. Quiet raised hand for the next one. I want to try to call on new people as much as possible. Anna, go for it. 12x cubed like that. Careful. So this is x to the power of 1. So it's negative 12x to the power of, and you can call for support if you want it to.
I had it up first.
We all had it up, so like.
That's why I never go on speed, because it creates this debate.
It's 4. It's 4. She called my name.
It is 4, because whenever you don't have an exponent, you assume that it is 1. So Brian, can you give the 50 XP to both Anna and Beverly? Thank you.
It's okay. I'm gonna be positive and not let this affect me. Go ahead and do that.
All right, the last one. The last one. Sam, go for it. It is indeed 24x to the power of 3. Thank you, Sam. That's how I use the area model. The answer is adding these all together. So the area is everything that I just filled in here. All of this stuff on the inside, that's the quote-unquote area. If I add all the area together, sometimes I do have to combine like terms. For most of these, for today, we don't have to combine like terms. Tomorrow, Well, not tomorrow because that's the quiz. The day after that, we will have to combine like terms. So my final answer is 18 x to the 5 minus 12 x to the power of 4 plus 24 x to the power of 3. I just add everything that was in the box. That is my final answer using the area model. Questions? Moving on to example 3 and then example 4. 3 I will do with you, 4 you're on your own. Let's do example 3. I need to multiply these two together. So you can choose whether or not you want to use the area model, but I am going to be forcing you to do the area model pretty soon, so you might as well get used to it. Try using the area model. I know some of you don't need to, but you will eventually need to. Area model. Set it up. 5k to the power of 3 and 2. That's going to be multiplied by negative 4k. Each term gets their own cell, or each term gets their own column or row. So it's going to be a 1 by 2 box. 1 by 2, I don't know what I would call that. A 1 by 2 area. Question, Jaden.
I have 2 questions.
All right.
So, yeah, do I get XP for doing the proper hand signals?
No.
Okay. Should be integrated. Also, second question. Anything outside of parentheses is what goes on the left side of the box?
It actually doesn't matter what goes on the left or the right. You just need to make sure that each term has their own row or each term has their own column. I just did it this way because I think it would save space. Yeah, so his question was, well, can't I do negative 4k on the top and 5k cubed and 2 on the right or the left? You could do it that way. It doesn't matter. Both of those are the same. All right, quiet raised hand. This one, Ellery, we'll give you preference. I'm sorry that Beverly spoke over you that one time.
It's okay. It's going to be negative 20k.
It is indeed negative 20k to the power of 4. Thank you, Brian, for recording Ellery's 50 XP. And what is the last area? Lorea. Ooh, careful. Something is wrong. It is indeed a negative 8k. Good job. Good catch. All right, and then write down your final answer. You just add those together, so I get negative 20k to the power of 4 minus 8k. Done. Box it. Which is funny because the other one is box 2. What you are about to do now, if there are no more questions, is you will set up your area model for example 4 and multiply them out. Are there any questions before we work on example number 4? All right, work on example number 4. Help your friends around you. I will be calling out XP so that Brian can log it. Brian will also be looking as soon as he finishes. Be working on example number 4. Thank you. We're back. I will set up the area model really quickly. So I have negative 8v squared, 7v to the power of 7 plus, well, I don't need the plus, I guess, 4v squared, negative 6v. It's going to be a 1 by 3 container. All right, first volunteer, Sam.
Negative 56
To the power of 4.
Oh wait, actually, never mind. To the power of 9.
Handwriting error.
Yeah.
Good job. Okay. Yeah, 50 XP to Sam. Next, Caroline.
Negative 32
Good job. And lastly, Ellery.
Positive 48 to the third power.
There it is. And writing them all together, that is not your answer. You have to rewrite it. Negative 56v to the 9 minus 32v to the 4 plus 48v to the 3. Box your final answer. That is all. All right, so Khan Academy, do your summaries at home. Don't do the summaries in class. Any questions before I end?
Oh my god.
All right, good luck on Khan Academy.